Alright, so next we're going to take a look at factoring trinomials, and we've already taken a look at how trinomials can be factored out when the coefficient value really is 1 or when we can see a common factor. But when we're factoring trinomials that have coefficients in front of the term that isn't 1, then we have to change kind of our method a little bit in how we do this. So asking ourselves what two numbers multiply to give you the last one and add to give you the middle one, it doesn't really work. We just need an extra rule in place to kind of make it work for us. So when there's a term in front of our squared variable other than 1, we must use the kind of the OI, so the OI and FOIL method of factoring. And so that's the part really that we're going to get into next. So we're going to see an example here where we factor the following trinomial, and we have 2x squared plus 9x plus 9. And so in this case, what we actually have to do is we have to take the first term and the last term. So 2 and 9. And what we have to ask ourselves, setting it up the same way we did before, what two numbers multiply to give you this and add to give you this. But here's where our rule changes. The multiplication step is actually the first term times the third term. So it's actually the x squared term or the squared term times the constant. So here, 2 times 9 gives me 18. So I need to think what two things multiply to give me 18, but those same two things can add to give me 9. And so when I look at my common factors between 4 and 18, because now I can kind of run through this in a similar fashion to find out what these two numbers are. So the added rule here really is to understand that we have to take the first term multiplied by the third term to give us the value that we're trying to look to see what needs to multiply to give you that value, and then add to give you the middle one. So remember, the middle term here, there's two 9s in the question, so I want to be clear on it. The middle term is the second term here. That's where that 9's coming from. So if I take a look at 18, 1 times 18, 2 times 9, 6 times 3, it looks like 6 and 3 are going to be the ones. These two numbers are going to be the ones that make up the OI in FOIL. And so what we would actually do here is we would take our values, okay, our 6 and our 3, and understand that our 6, so 6 and 3 and 6 and 3, and then we would understand that we'd have a 6x and a 3x that's going to make this work. And so kind of here's how we would solve it out, or how we would do it, really putting together a couple different pieces here. So I'd rewrite my first term out, 2x squared, and then my 9x can get broken apart into these two terms that we just found, because 6x plus 3x give me 9x. That's the outside inside part. So I'd have a 6x term plus a 9x term, sorry, 6x term plus a 3x term that I could take out and split apart. Because really 6x plus 3x makes 9x. So I'm not changing the expression any, I'm just using our factor and this idea of these outside-inside terms to figure out what I need. So after that, I'm going to do some common factoring. And how we do this is we group together our first two terms. So I'm going to put brackets around my first two terms. And we group together our last two terms. So I'm going to group together our last two terms. And then I'm going to look for a common factor here. So between 2x squared and 6x, it looks like I have a 2x in common. And then I'm going to write what's left over. So if I take out a 2x from the first term here, I'm going to have an x left over, because 2x times x is 2x squared. And then it looks like I'm going to have a 3 here, because 2x times 3 is 6x. Then I'm going to add that to a common factor for my second two terms. So it looks like between 3x plus 9, I can take out a 3, and I'm going to have x plus 3 left over. Now, we did a problem like this with common factoring. They were type 2 common factoring problems. And so I could factor out an x plus 3. So that's really what's here, x plus 3. And then what's left over? 2x plus 3. So I can use these terms to really help me figure out what I need to get to. right? So really, I guess when I wrote these ones out, I should flip them just to make sure that I'm being correct here. So, because really when we take a look at our outside term, 2 times something gives me the 3, so 2x times 3 is 6x, and 3 times x is 3x. And so, really having this kind of idea of this common factoring approach will help us do these hard trinomial questions, or help us do these type 2 problems where the a term isn't equal to 1. So, let's take a look, and we're going to run through some together here. So, 3x squared minus 10x plus 8. So 2 things that multiply together, and remember here we're looking for the first term times the third term, so 3 times 8 gives me 24. Then those same 2 things are going to add together to give me negative 10. So I need to try to come up with 2 things that multiply to make 24, and those same 2 things can add together to give me negative 10. So I start making my lists of factors to see if anything kind of pops out right away that might work for 24. And those same 2 things have to have a difference of 10 or add to make 10. And notice it's a negative 10, so either one of them or both of them in this case are going to have to be negative, because when I have 2 negatives multiplied by each other, I'm getting that positive 24 out. So it looks like the 4 and the 6 are going to be my factors here that I'm going to use. So minus 4 plus minus 6, or negative 6, gives me negative 10, and negative 4 times negative 6 gives me positive 24. So it doesn't matter which way you write them. I'm going to start with my first one, 3x squared minus 4x minus 6x plus 8. And so remember that really what's happening here is my middle 2 terms are really just still combining together to make negative 10x. So I'm not really changing the question any. Then I'm going to put brackets around my first 2 terms, and I'm going to put brackets around my second 2 terms. Now I'm going to factor out what's in common in the first set of brackets, and it looks like there's only an x in common. So then I'm going to write what's left over, 3x minus 4. Then I have a negative 6x, so I'm going to take out a negative because I want that first x term to be positive. Once I take out the negative and then I look at 6 and 8, I can see that there's a 2 in common here. And so my 2 is going to make it so I have negative 2 times 3x is going to give me negative 6x. And a negative times a negative is going to make a positive. Oh, and then 2 times 4 is going to give me my 8. Then I see that I have a common type 2 factor problem where I have 3x minus 4 in each set of brackets. So I'm going to take out that 3x minus 4, and then what's left over is x minus 2. And so this would be my factors for my type 2 trinomial. And I could go through the same way and expand it back out and make sure I have the right answer, because all I have to do is FOIL this out to check and see. So my first 2 terms would give me 3x squared. My outside terms would give me 3x times negative 2 is negative 6x. My inside term would give me negative 4x. And then my last term would give me positive 8. And so really if I look at these, they kind of match up to my terms that I'm getting here. And so I know that when I combine these together, I'm going to end up getting my negative 10x, my positive 8, my 3x squared. So I know that I'm on the right track. Alright, so let's try to factor this one out. Factoring out the following trinomial. So I've got 5x squared plus 7x plus 2. So in this case, same steps as before. We're going to take 2 things that multiply to give you the first times the third. So 5 times 2 in this case is 10, and those same 2 numbers have to add to give you 7. So 5 and 2 looks like it's going to be my numbers that are going to work for this one, because 5 plus 2 is 7, 5 times 2 is 10. So start with our first term, 5x squared, and then I'm going to add in 5x, and I'm going to add in 2x. So notice that the 2 numbers that I pick really just pick up the variable on the middle term. So even though I picked 5 and 2 for my numbers at work, I have to remember to include those x's because it's the middle term that's really being separated. Right, 5 plus 2 gives me 7. I need the x's there as well. Then we're going to bracket the first two, we're going to bracket the last two, and I'm going to look for some common factors here. So in the first one, it looks like I have a 5x that's in common. It gives me an x plus 1 left over, because 5x times x is 5x squared, 5x times 1 is 5x. Looks like in the next one that I'll have a 2 that I can take out, and a positive 2 of that, or a plus 2. So after that, I really have x plus 1 left over. Type 2 common factoring problem, x plus 1 is in common in each one, and then what's left over is 5x plus 2. And then I could go through and I could expand that out and see if I get back into here again by doing my FOIL method to check. And so I'd have x times 5x being 5x squared, plus 2x plus 5x, which is good because that's what I had here, and then plus 2 as my last term. And so I know that I'm on the right track. So I'll get you to try this one out on your own, and pause the video, give it a try, and come back when you're ready. Alright, so in this case, we're doing the same steps, two things that multiply to give you a value. In this case, it's going to be the first times the last, same as before, so 4 times 6 is 24. And then those same two terms are going to add to give you negative 11. And so when I look at factors of 24, there's a whole bunch that are there, but there's only really one that multiplies to give you 24 and will add to give you a negative 11. So remember, if I have a negative value as my addition term right here, that means that both of these are going to have to be negative, right? Because a negative times a negative will have to give you a positive value. So I know these numbers are going to end up adding together. And so 8 and 3 are the ones that kind of come in mind when I think of multiples to 24 and then adding to make 11. So same steps as before, 4x squared minus 8x minus 3x plus 6. We're going to group together our first two terms and our last two terms, and then I'm going to look for a common factor between 4x squared and 8x. Looks like a 4x is going to be in common here. So 4x, and then I have x minus 2. And then in the other one, it looks like I can take out a 2, so I can take out a negative 2 because I want my x term to be positive. And then it looks like I'm going to have x minus 2 as well. Type 2 common factoring, so x minus 2 is going to come out, and then what's left over, 4x minus 2. Again, I can FOIL that out to double check to make sure that I'm on the right track, but I should be okay with this. So 4x squared so if I took a look here, just as I'm staring at that, something didn't quite seem right away, so let's take a look. X times 4x gives me 4x squared. My outside terms are minus 2x. My inside terms are minus 8x, and so I do have something here that's not quite making sense, and I see it now what it is. So I wrote a minus 2 here when I took this out, when really this one should have been a 3. And so really I should have 4x squared minus 3 as a value here. There we go. That makes a lot more sense. And so I guess it's kind of a lesson here in terms of, verifying your answers to make sure that you're on the right track, because I would have missed that otherwise. If I just kind of left it alone, it would have been incorrect. So first terms would be 4x squared. Now my outside terms are minus 3x. My inside terms are minus 8x. There we go, because now I'm getting these back. And then I've got plus 6. So factoring hard trinomials or factoring type 2 trinomials, they do take a little bit of work to get through and practice to go through. So I've got 3 here for you to try out, so I'll get you to pause the video, give them a try, and come back when you're ready. Alright, so in each of these cases, you're trying to look for, again, two things that multiply, in this case, to give you negative 60, and those same two numbers add to give you 11. In my second set of problems, I'm looking for two things that multiply to give you negative 30, and those same two things are going to add to give you negative 1. And in the last one, we're looking for two things that multiply to give you negative 36, and those same two numbers are going to add to give you negative 9. And so, once we come up with those, then we just follow our same steps of our common factoring. So, if I look at 60, I need to come up with something that's going to give me 11 as a value. Notice it's negative 60, which means one of them is going to be positive and one's going to be negative. And then when I think about the positive and negative side of things, knowing I'm going to subtract, 15 and 4 kind of come in handy here. And the 4 is going to be my negative because I have a positive 11 term when I add them together. So then after that, if I go through my common factoring stage, what I can see at the end here is that I get 5x minus 2 and 2x plus 3. With minus 30 and minus 1, or negative 1, we have negative 6 and positive 5. That look like they work out. And so again, if I write them out, I do my common factoring step, 3n plus 1 and 5n minus 2. And then in the last one, 36, looks like I'm going to have, and again I'm going to have two things that are separate here, looks like minus 12 and 3 are going to do that trick for me in this case, to come up with them. And then again, I'm going to split that up, I'm going to look for a common factor, and I end up with 3x plus 1 and 3x minus 4. So hopefully there's a little bit of practice there for you to go through. I do have one other activity here, and I'm just going to basically end the video at this point, but this is kind of something that you could pause and you could work through for some extra practice. It's just a little puzzle to go through that you'd fill out a little joke on the bottom at the end. So hopefully that made a little bit of sense for these type 2 trinomials where the a term isn't 1. And if you have any questions, let me know.